Hi, and welcome back to day 3 of chemistry tutorials over stoichiometry. Today we're going to go over your mass to mass homework. These are the longest, ugliest problems of stoichiometry, but some students actually like mass to mass because they know exactly where things go. You'll be converting grams into mole, you'll be doing a mole ratio, and converting that mole back into a gram on each problem. So yeah, there's a lot involved in this. So the first thing I'd like to do is balance our equation. There's 2Ks, so I'm going to start off by putting a 2 in front of this so that we could have 2Ks here. There's one set of SO4s, there's one set of SO4s, we're good. Calcium, calcium, and that really was the only coefficient needed. Fantastic. So I'm going to keep up with the consistency of highlighting my given, and I'm going to underline what I'm looking for. You'll notice when I did that, both of them say grams, so that hence mass to mass is our homework tonight. We will be starting in grams, converting to mole, doing our mole ratio, and converting back to grams. You'll notice today I'm not going to use the foldable. Some teachers may have handed out a manipulative to help. We're going to walk through the logical progression. We're starting with 20 grams of calcium nitrate. So just like we have learned all through January and now most of February, whatever we start with, you got to have on the bottom. We call it the disco method. And we're converting that into a mole. So you'll notice that everything still is the given chemical. Now, I do apologize where it says you might need more room to show work. I'm one of those people because I write awfully big. I need to do the molar mass of calcium nitrate. It looks like there is one calcium that weighs 40.078. And there are 2 nitrogens that weigh 14.007. And there are 6 oxygens that weigh 15.999. Again, if you want to do this all in your calculator, that would be perfectly acceptable. 40.078. You do run the risk of typing one number in wrong and ruining all your work if you type it all in at once, especially when I'm talking and typing. Okay, my total mass is 164.086. And that's what's going to go right there. Okay. So now we're still trying to get to our mole ratio step, which I told y'all I would circle throughout the consistent videos back to back. Calcium nitrate. And this is the first time we'll be able to talk about what we're looking for, because this is our mole ratio step. So this is grams of potassium sulfate. I'm sorry, moles of potassium sulfate, because it's a mole ratio. We're going to have to convert it to grams over here. So for every, calcium nitrate, every 1 mole of calcium nitrate, there is 1 mole of potassium sulfate. You have to be careful because I almost did potassium nitrate before I caught myself. So you have to be very careful to write out everything. That's why it's so important to write the chemicals here. And from this point on, everything is about what we're looking for. Outside of the mole ratio step, mole is always 1. And then we're looking for grams of K2SO4. Oh man, another Post-it. Y'all are going to love it. All right. So we're still doing molar mass. We have 2 Ks, we have 1 S, and we have 4 oxygens. Most of you have probably memorized the mass of oxygen. 39.098. Again, the idea is that you will multiply, add them all together for a total mass. I'm going to let the calculator do that for me. 2 times 39.098 plus 32.066 plus 4 times 15.999. 174.258 goes right here. So now we're going to multiply the top. 20 times 174.258. We're going to divide by the bottom. 164.086. So your final answer, we would want 3 sig figs. So my final answer, which I ran out of room to write, so I'm going to box it over here, is 21.2 grams of K2SO4. The thing that students do not like about these problems is that generally you will have to do 2 molar masses because it is a mass-to-mass problem. I'm going to keep these Post-it notes handy for the next one because if we're dealing with one of the same chemicals, then we can just use the molar mass we've already calculated. Okay. So I'm going to choose to do the next one right here. I'm going to start it over a little bit further to the left so maybe I can fit my answer over here. My given is 3.9 grams of potassium sulfate, 3.9 grams of K2SO4, and so I'm going to have to write grams of K2SO4. Okay. Oh, snap. You might want to keep an extra worksheet next to you or a blank sheet of paper where you actually keep track of these masses so you don't have to go and reinvent the wheel. You can actually say, oh, I already calculated that in the last problem. So there it is. And that's how much 1 mole of K2SO4 weighs. So now we're ready for our ratio. If you're in moles, that's when you need the coefficients. So I'm going to put moles of K2SO4 so you can see that we're still talking about the given here. And now, since we're in our mole ratio step, that's when I can start talking about moles of calcium sulfate. So for every, let's see, potassium sulfate, for every 1 potassium sulfate, there is 1 mole of calcium sulfate. These are not always 1-to-1 ratio. I don't want you to get scared from this video. I'm doing all this work for nothing, because these just happen to be 1-to-1, okay? All right. So now for outside of the mole ratio step, mole is always 1 for every 1 mole of calcium sulfate. Oh boy, I haven't calculated the mass of calcium sulfate yet. It's going to be grams of calcium sulfate. There's 1 calcium that weighs 40.078. There is 1 sulfur that weighs 32.066. And there are 4 oxygens that weigh 15.999. Again, the idea is you multiply, and add them up. 40.078 times 32.066. Did I just multiply those two numbers? Yes, I'm sorry. 40 32.078 plus 32.066 plus 4 times 15.999 gives me 136.14. While I already have this number plugged in the calculator, I'm going to times that by 1, times that by 1, times it by 3.9. Then I'm going to divide it by 174.258. So my final answer would be, to two sig figs, 3.0 grams of calcium sulfate. I'm going to do one more problem with you because this one actually has something that's not a 1-to-1 ratio. We got 8.4 grams of potassium nitrate. So my given is potassium nitrate. Which we have not calculated the mass of yet. Ooh, I'm going to run out of Post-it notes, guys. So the molar mass of KNO3, K is 39.098. Nitrogen is 14.007, and oxygen is 15.999. So 39.098 plus 14.007 plus 3 times 15.999. That gives me a total mass of 101.102. So I'm going to put that right here. 101.102. And that's how much 1 mole of KNO3 weighs. So we are still talking about KNO3, but now we are able to do our mole ratio step. We will compare moles of KNO3, and we are, sorry, now I can't find what I'm looking for because I forgot to underline it in the problem. We're looking for calcium nitrate. So I'm going to do moles of calcium nitrate. KNO3 has that coefficient of 2. Calcium nitrate has a coefficient of 1. Outside of the mole ratio step, we always use 1. And of course, this is still what we're looking for. And then we have grams of calcium nitrate. So we're just converting that mole back into a gram. And I know I already calculated calcium nitrate because, sorry guys. Calcium nitrate was 1 calcium, 2 nitrogens, and 6 oxygens. So it was 164.086. Now, there's 2 ways to actually mathematically solve. You can just multiply the top and multiply the bottom and do a separate division problem. I prefer to put everything in the calculator at the same time. 8.4 times 164.086 divided by 101.102 divided by 2. Anything on the bottom, you just hit divided by. And that gives you 6.8 grams of calcium nitrate. So basically, you multiply everything on the top, and then if you hit division sign 101.2 and division sign 2, it will give you the right answer. All right. I'm going to balance one more equation just so if that's the only thing stopping you from doing the homework, you got it. I wish you good luck on these problems. Again, I would highly suggest that you highlight the givens and that you underline whatever you're looking for. So that way each problem, it's very clear to you as to what goes into the T-bar first and what should be in the last part of the T-bar. I hope this helped you guys. You have a lot of work ahead of you. Good luck, and we will see you tomorrow.